Hello everyone, it's June the 2nd. I'm a bit late today because I had lots of meeting in the morning. But anyway, doesn't really matter. Let's get right into it. We're gonna have today interleaving string. What does interleaving even mean? Oh my god, look at this. Huh. Alright, given a string S1, S2, and S3, find whether S3 is formed by interleaving S1 and S2. An interleaving of two string S and T is a configuration where they are divided into non-empty substrings such that blah, 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 n minus m smaller or equal to 1. That means either I have one more on the S substring or one more on the T substring, and then interleaving, just put them as T1 or T1 as well, okay? Note A plus B is the concatenation of string A and B. Okay. So we can do AA and BB and C. And this we can do D, B, B, C, and A, and then that is a interleaving string. Ooh wee! Oh man. S1, S2, S3, they consist of lower English letters. Can you solve it? Only use S2.length additional memory. Memory space, don't worry about it. We can always figure that out later. Alright, let's solve this one first. So whether it can interleave. Okay, so our example is AABCC, DBBCA, and I want to see if they can interleave into AAD, BBC, BCAC, right? Man, where do we start? I don't even know how many to interleave. Given that we only have 100 on each one, which means we're looking at something ridiculous, some ridiculous dynamic programming. That's what I think. Okay, interleaving, so we split them up. There are so many different ways to split them up. And we cannot try every single one of them. I mean, we can do comparison, right? Because if it's interleaving, then the start must match some of them, right? Well, it's also possible that the start will match both. Like if I have the same start and it matches both. I mean, we can try both, right? It doesn't matter because it has to be S1, S2, S1, S2, S1, or S2, S1, S2, S1, S2. So there are only two possibilities. So let's just say we're going to match S1 first. So we say we have our S3s here. We're going to match S1 until we cannot match anymore. So we match S1, we match AA. So we cannot match. Then we need to match S2. Right? So we start from D, and we also know it has to be from the start. So D, B, B, C, we can match D, B, B, C for S2. Then we cannot match. Then we go back to S1 and we match B, C. Then we cannot match. Then we go back to S2, we match A. And then we finally go back to S1, we match C. Okay, so that's like a good scenario. But I can see how a tricky case will happen, right? As we are matching, we're matching a lot more than we're supposed to. It's like it's like if we say AA, we match, right? And then match DBB, let's say just DBBC. What if it's an A here, right? And then we can match all of S2, and then that will not be right, and because the remaining of it doesn't match in S1. And that means there has to be like backtracking. Are we going to backtrack every single one of them? Like every letter? Like if we match? Like we say we start from match A, right? And we match A and A, we match. And then, because we have to match at least one, right? After we match one, then we go to the second one. And the second one, we have two possibilities. Every letter has two possibilities, right? We either match S1 or we match S2. Then we try to match S1 and we say we match, and then when we match S2, we say we don't match. So when that happens, we know it has to match S1. So if we can match both, like for any position, we can match both, then we need to bifurcate, right? We have to do two calls. Okay, we have to do two calls. That screams dynamic program. We need to cache. We need to cache something. So how do we cache? Cache means at a certain position, right? If at a certain position, so basically we think about like this, right? So we have a string, and we're looking at only one. We're only looking at one, right? We're looking at one letter, and we say, does this letter match S1 or match S2? If it matches S1, then we say we need to match the remainder with S1, the remainder, and S2, right? That's a subproblem. And if it match both, then we go both, right? We go both. Now, where does the caching happens? Cache basically just means if we given a position, right? A position, we want to know whether it's a match or it's not a match, right? So we have the position. So the ultimate we want is the position on S3, right? If S3 is 0, S1 position is 0, S2 position is 0. That's what we want to know, right? Whether this one is a match or no match. So we can compare, right? We can compare. If so, to do hold on. To do 0, 0, 0, right? We can compare, and then we say these two match, these two does not match. Then the next state will be 1, right? 1, 1, 0, right? We're gonna match 1, 1, 0. Okay, so we start from 0 position, and then we have that's a table, right? That's a table. Oh, it's a little bit. It's a table. So I'm trying to think about this from bottom up instead of from top down. Okay, bottom up. That's not a. I was thinking about top. That's bottom up. That's different. Bottom up is different. So bottom up is I'm at my current, right? I'm at current and try to see which one I shall match. I don't care about the remainder. So if I have A, then I know I have to match S1, right? And that's good. So, which means it's true. We have no. Hold on. Doesn't make sense. That does not make sense. Because if I go bottom up, I say I'm current at A, and I see this is A, so I say I match S1, and then the next one, I say either match S1 or S2, so I match S1. That just feel weird. I want to do top down. Seems easier. I just want to say, top down is in order to see if this whole thing match anything. I want to see if this matches one of them, and then I want to know if the remainder, how does the remainder match? So the remainder can be, is the remainder start also from S1? That's fine, right? It's also from S1, and if it start from S1 and we can end as S1 or S2, it doesn't really matter. Yeah, so we have a start, so we just say if the remainder match, then we match. So we say this one, we match S1, so now we consider the rest. And then for the rest, for each letter, we can have two different matches. Yeah, that's fine. You can have two different matches. So the problem is still how do we cache? How do we cache? I have a position on S3, right? And then I say, if I can bifurcate into two different matches, so I can say I can match S2 and I can match S1. I can match both. So I start matching both. And as we go on, yeah, I think it's just the index, right? The index of S3, index of S1, index of S2. This will form the key to the cache, because it will be the same problem. Like if we say we start from this position on, and we have S2 at certain position, S1 at certain position, does this create a match? And we're going to return once a match is found, right? Once a match is found, then we don't have to keep going. Let's try this. Let's try this. Let's try this idea. Definitely not like, okay. Huh. I never showed up yesterday. I did this exact same thing yesterday. All right. Okay, let's give it a shot. So I can foresee this to be actually quite easy to write. Right? So we have these three, and then we just say def helper, right? And I see this one as a from functools import LRU cache. So I think this one we can cache it at LRU cache. I think we can say max size equals none. Right, we don't care. So we have IJK, right? IJK. So I is going to be S1. I just call it I1, I2, and I3, right? So the corresponding to the indices of each index of each string. And where is the end? Well, the end is when I3 is larger than if I3, right? If I3 is equal to len S3, okay, let's also make it like n1, n2, n3 equals len S1, len S2, and len S3. So I say if I3 equals to n3 and, oh yeah, and that's like when they all hit the end, right? And yeah, I think this is when we can just do like say I1, I2, I3 equals to n1, n2, n3, right? So when that happens, that means everybody has reached the end, which should be the case, right? If I am at this position, right, and I'm trying to match, this one's already matched, so this one's going here, and I want to try to match here, and then we do match, and both increment, and then we have this, and then we return true, right? And if I1 is larger than N1. Hold on. If so, that is a true. What is a false? What is false? If there's no match, is a false. Right? No match. Yeah. So I think we can keep an eye on this, and just to see, like, if we have, yeah, if any of these, no, let's do it again. If there's a mismatch, right? If I have a letter in S3 that cannot be matched to anything here, then that's a no-go. Or if I have a letter here, and then we exhausted these two already, that's a no-go. Or if I exhaust S3, but there's still something here, and that's a no-go, right? So we have a couple of situations that's a no-go. So if this, right, and if S3, right, if I3 is equal to N, then N3, and I1 is smaller than N1, or I2 is smaller than N2, and that's a false. Right? That's a false. After these two conditions, then we can be sure that I3 is smaller. So we can always pick something here, right? And then we can actually check all of them. Like, there's a lot to check. Hold on. Because we can have, as long as if this one is not exhausted, and one of these has exhausted, that's actually fine, right? That's fine. What is not fine is this is exhausted, but one of these has not been exhausted, or these two has exhausted, but this one has not been exhausted, which I can actually test as I'm doing, so it's fine. So let's do this. So we know I3 is good, so we can know the current letter, right? We know the current letter, and we're going to say if right, if I1 is smaller than N, N1, and S3, I3 equal to S1, I1, that means we match to this, right? That means we match to this. Then we say, if we match to this, then we say, we're going to call helper, I1 plus 1, I2, I3 plus 1, right? That's what we call. And again, if it's true, then we're going to return true immediately. If it's false, then we'll keep trying, right? And then if I2 smaller than N2 and S3, I3 is equal to S2, I2. So we match S2. So I think it's the same code here. And then we say I1 doesn't change, but I2 increment. Again, if it's true, we always have been true. If it's false, so basically they just say we tried both. We try to match both, and then we can return false. Right. And then we have a cache. So what we're going to do is we're going to return helper. Right. So helper will return a Boolean value. So we're going to say return helper 0, 0, 0. right? All right, let's try to see the test case. Okay, try to see the test case. No, okay. All right, test case. The first one is AABCC, D BBCA, and AAB AD BBCB CAC. Nice. Second one, exactly the same on the front. I think just the last one is different. And the last one is AA D BBB ACCC. Right? And this is the extra case, which is just empty. Oh, I forgot to say true or false. So this one is true. This one is false. Okay. So we're gonna find this is going to be S1, S2, S3. Right. This is interleave S1, S2, S3. All right, let's take a look. I passed all three. Looks promising, so we're going to try it. Delete all these. I have a white space. Okay, so line 7. Okay, give this a shot. I don't have high confidence, but we can try. Pending. Accepted. Oh, we got it right. I think this is the solution. But I doubt this. The time complex, the space complexity is what is required. So this is a DP. It's a pretty naive DP solution. The logic is that for each letter, right, in S3, we can try to match it to S1 or S2. If it matches to any one of them, we move on to match the remaining. If it matches to both of them, then we bifurcate. With this logic, each recursion call has a state represented by the current indices of on, S1, S2, and S3. Therefore, we can build a cache on top of it to save repeated computation. I do not know the runtime. This one, I mean, the worst case scenario is for each one I match one of them, and then it doesn't work, and then we match. I think the runtime is this times this times this. That's my guess. Because for each one, we have to go through every single one of this, right? Then for each one, we can match match this, and then I don't know. That's runtime. I have to see the bottom-up solution to know the runtime, which we're gonna do. We're gonna try to do the bottom-up as well. So let's just find the runtime. So runtime is 44 milliseconds, like a 35% ranking. Yeah, it's hard to see the runtime. Actually, I never know how to do runtime in this type of recursion. I mean, we are, in worst case, we're bifurcating for each one of them, right? In worst case. So for each letter, we can bifurcate. For each letter, we can bifurcate. But because we have caching, so that means I want to say I don't know. I mean, we can bifurcate for each one, and then yeah, I think the runtime is just because the combinations, right? This is the combination. Like the worst case scenario, we have all the combination of I1, I2, I3. So I think the runtime is O, worst case scenario, MN that's K, right? Where M and K are the lengths of S1, S2, and S3. That's what I think. Worst case scenario. All right, now we solve this. The next thing we need to do is to try a bottom-up solution. Right, bottom-up solution. So a bottom-up solution will be the same idea, right? We have 3. So that's we're talking about a 3D matrix. Right, so 3D matrix, and whether it is possible is based on whether the remaining is possible, right? So we can go from the from this one going back, right? Like actually going from front. The first one is possible, and the second one is possible, and then how? I don't think we can go from front. Yeah, I think it'll be easier to think from the bottom up, from like we check this, right? So anything we check based on whether any of these, whether this one is possible, right? So we do it from here, and then once one of them is not possible, and that's a no-go. So anything will be, yeah, so we check this, and we check this if it's matching. If it's matching, we keep going. If it's not matching, so it will be, hold on, if I have 2 matches, right? If this one has 2 matches, and then whether this one is a match or not depends on 2 different scenarios on this one. Hold on. Whether we have a match for both, right? We have a match for both. If a letter can match to both, so we don't know which one to match at the current stage, then we say, I mean, what matters is whether this one is a good match or a bad match. So from this one going forward, it's a good match if something here is a good match. But the thing is, if I match, it's fine. Like we can, Like what was the problem? The problem is we don't know which one to match, right? If we go front. If we match one, and if we keep going, that will give us trouble. It might give us trouble. So we need to say we either match this one or we match this one, right? And then from bottom, going bottom up, if we hit one, then if we say we can match this one, we can match this or match this, then it doesn't matter. We just say both will be true because they all match. Let me think. This means like at the position for C and position for So for I have I3, I1, I2, I3, right? And then that's going to be a true. So the idea is we want to know 0, 0, 0, whether that is a true or a false. In this case, let's just try in this case, see why this one is not a good. So at bottom, we say we match this, and the second one is also a C, right? And we say we have to match this, and the third one is also a C, and this is a no match, and this is a no match. So we have no match. Then that's already a false, right? That's already a false. And what if we can match both? What if like this is also a C, right? And we say in this one we can match both, and both will be true, right? Both will be true. And then we keep going here. So this one, how do we match this one? So this one, because here, if I match this, right, then this can match to either this one or I feel like if I go backwards, I think I'm almost there, but just a little bit not there for the bottom up solution. What if I match both? What happens? So we just say I3, I1, I2, I3. It's going to be that's a true, right? So with the last one we can all match. So it's like now we'll go one back. So if that's a match, so we record that's a match. If that's a match, we'll also record that as a match. And then once we've done both, then C is gonna move one to the front. Now when C move one to the front, how do we know where I is? Oh, hold on. We iterate through. That's the iteration. Yeah, that's it. I think that is the iteration. So give currently. Hold on. Try this again. Try a matching case, right? Yeah, I don't like string. I don't like string at all. So, and we also have the last case. So the last case will be matching, but then this will be a non-match. This. So from the last place, we're gonna compare to everybody. That's a no match, right? And then last and this, that's also a no match. Only this is a match. Okay. So the last place we're done. Now we do the first place. So the first one we can also iterate through. So we can do the last character C. Right, so for each one, like for this one, each one, we can say I want to match at any position. Right? I want to match at S1 at this position, and I want to match S2 at this position. Right? And I can put a star to each one, right? And then we can say this one I want to match this, and I want to match any of this position. This one can match. Yes, I think yes. I think I know. And then we can go front to back, right? We can do front to back. It's like first A want to match this, all want to match this. That's the first letter, right? The first letter I can match to nothing on, I can match to 0, match to 0, match to 0. No, only match 1. So 0 match to, yeah, that's a true, right? So like S2 is at 0 position, and we say all these three are at 0 position, that's a match. And if this is a 0, and this is like not a 0, and this is still a 0, is that even possible? So S3 is only one position. So both of these has to be only one position, right? Both of these has to be one, only give one position. Which means if this is one position, then that could be either one of them, right? And then we go to the second position, right? If we match this A, then we can match from the start. Like the sum of these two cannot be larger than 2. But where's the DP part if you do it this way? And gotta be a I still cannot figure out the DP for bottom up. Let's go back from the back to the front. So we're at the back, and we say anything can match to the back. Right? We can match the C to this. We can match C to this. How? When we end, like when we end, one of them has to match the end, right? And if we do have a match, then we can move one of them backwards, and this one still stay here. Then we go to the next one, and next one. What if they both match? That's still the same problem. Like if only one of them match, it's fine. It's when they both match, right? What if they both match? What if they both match? C, right? Yeah, I'm just thinking like, what if this BBCC, right? Then the last position, they both match. Now we don't know which one to take, right? And I say we can take DP means just I take all the situations. Like I don't care. Like if I could take the first one, then No, I don't think this is like analysis. This should be like just scan it. Like all we want is all the possibilities, right? All the possibilities. Like if I'm given a 3-letter code, three digits, each one representing the index in the string. Given that, I want to know, based on my current standing, if I can find a match, I want to know if my next one is a match. Right? That's it. That's all I want to know. Right? If I am a match, whether my next one is a match. So we start from the bottom up, and we're gonna add a thing at the end. and we're just gonna compare. Say if I am at the last one, and then S2 is at the last one, and S1. So if these two are the last one, and S1 can be anything, it doesn't really matter because we match on S2, right? Is that what it is? Like we can match anything. S1 can match anything because we don't care. Yeah, say if like I have C here and I match this to C, right? Then like if C is here and then I match S1 as a match, then that means in this situation, this is here and this is here. I don't care about S2. It can be anything, and then we can all match because yeah, that it doesn't concern S2. And then we can keep going if this one's here, and S1 is this one, and that is a no match because this is not a match, and this is also not a match. Yes, that's true. And then we can go through everything. And then we go here, and then we go this one. If this is this, and this is here, and we have a match, what does that mean? It means one is at the end, and we want to match another one that's not towards the end. Isn't that like a no match? Yes, what does that mean? Like if given a position of S3, and I can give you any position in S1 and S2, and what does that mean? And that means it's a no match, right? Because if I am here, that means the number of letters remaining must be 1. No, like it's here. Yeah, number of remaining has to be the same as here, then as the number of remaining. No, yeah, that's a no good. That we can compute. We can compute the number of letters remaining. The sum of these two must equal to this in order to even be possible for a match, right? Otherwise, it's not going to be a match. So those will all be false. So the only situation we need to take care of is, like this is 1, so it's either this or this, right? Only one of them. And then we say it's here, right? It's here. Then we say we have 2 remaining, right? And we can go here. Then we do this as a no match, and 2 remaining on all of the others are no match. And then we go here, and then we look at this. We have 2, right? Yeah, we are at here, and we have this and this. So we want to know if it's match. So we say these 2 is not a match. So we want to see if these 2 is not a match. That means this is not going to match. So this means we have to find this thing. This thing is pointing here. So what we need to find is that if this is not a match, that means we have to see if this is a match. Oh. Why is it so difficult? I mean, look at this. This is so easy to write. So I have 2 left, right? I have 2 left. And if it's nothing, if there's 0 left, and we go to 2 left, and you see, oh, that's not a match, right? That one is not a match. So 2 left, we have to, yeah, is not a match. Then, if this is not a match, then what we need to see is whether and when we find that something is not a match, right? This is not a match. Then that just means it's not a match, right? Yeah, I think that just means it's if it doesn't fit, that just means it's not a match. Then we just move on. And then we cannot move on because this is so now we're gonna do one of this, and one of this. And we're looking at here, and we say this is not a match. I don't know. How does this work? Or take this, take the combination of nothing, and I can go C, see if it's a match, CC if it's a match, BCC if it's a match, a match, and we know whether these two is a match, and then we go one of this, we take one of this, and take any one of this, and then we take two of this, any one of this, three of this, take two of this, like we take nothing of this at the end, and we take nothing of this at the end, and we match this. How many? Is it a match? No match. Right, when this is 0, and we have match, like no match, no match, no match, no match. And if we take as last as A, right, and it's done. And then say take as an A. It still doesn't make any sense. It does not make any sense. I don't know. Why is it so hard? How do we translate this to a bottom up? Right, if we match, then we move on to the next one. Right, so if we bottom up, I say we go from backwards, right? So we say we look for the last letter, and the last letter if we match to a stuff. The last letter, if I match to a letter, and we just say that's a match. I say this position and nothing position and this position give us a match, and all the other give us no match. Right, so like this position and all the other position give us no match. And now we go to AC, right? AC. So we're looking at A, right? And we know all the combination for the C. right? The combination for C is we can record it, or we can record it like anything. If nothing's here and one is this, and that's a no match. Nothing's here, one of this, that's a match. Okay, so now we're looking at A, right? We're looking at A, which can be nothing's here, then we need to look at this thing, and then that's a no match, right? Now if we have one thing is here, then we need a one thing is here, that's also a no match. And we have one thing is here, then we have a no match. If it's A, we can take nothing here. I don't want to take here. It has to be taken with this one, and that's a no match. Right? That's where we take nothing here. So if we take something here, we take A here, and that's a good, and then we need to take C, and that's a match. So we have a match. And we also say, okay, if I take A here, and I take 2 here, and that's also a no match. That's all the possibilities, right? That's all the possibilities. So given the last two letters is AC, the only possibilities are no 0 match here and 2 match here, 1 match on both, or 2 match here and 1 match this. And that's how we build it up. And then we look at this, C, and then that will be trying to match this, or we match 1 here, right? We want to want. So yeah, if we want to do this, and then we try to match this, and that's a no match. Now we want to match an A, which is a no match, right? So now we want to match CA, and CA is a match, and once we match CA, the problem becomes I want to see whether this and this match. Okay, that looks more promising. So we can match. We can match CA, and so we can do like some CA, and then the last one is C, right? Or we can do B, and B is a no match, so that's no go. But that's not how we match, right? We don't match CA. We match the A. Can we match CA here? C here. Then we have DBB. How do we match CB then? Yeah, like how do we match this C? This C, so this C is actually matched to this C, which means if this C is matching to this C, I'll have, and this A matching to this A, this C matching to this C, right? But all we know is this C needs to match to this C. Hold on. So each letter, so I can match this one. If I want to match this, we can match to nothing, right? We can match nothing as 1. Then we need to match this. That's a no match. And then we can say this one wants to match 1C. Then we need to check for the case of 0 and this and this, and that should give us a no match, right? And we can also match, say we match this C, That give us, we can match this one, and this. That's a match. Or we can match this. That's no match. So that's gonna be, we match S1 first. We also need to check match S2 first, right? We say match no S2, and we have to match this. Then we do this already. Yeah, we match 1, match 2, match 3, yeah? And then we say we want to match A first. Ah, that's the difference. We want to match A first, then S1, we're gonna match to here. Okay, that might be possible. That might be possible. But I want to try to write it. So the idea is we're gonna have a what? Oh my God, it's gonna be a something we've computed already. We're gonna do a 3 level, right? That just feel very, very convoluted. Can we do, say, like a dictionary? Dictionary. Otherwise, dp equals to, for, I'm gonna copy this. It's the first level for this in range N3, and for each one of them, it's gonna be this, which is going to be false, say times N1 for this in range N2, right? So we say N1 is going to be the column, N2, no, I want N1, now N3 is the top level, N3 is the top level, and then, actually I don't think it matters that much. Anyway, N3 is the top level, and then N2 is the second level, and N1 is the inner level. That's fine. 1, 2, 3. So we're going to do 3, 2, 1. Okay. So we're going to say, actually, I think it has to be plus 1. Yeah, I think it has to be plus 1. And it can also be, actually I don't have to, because I can just change S1 plus equal to a star, S2 plus equal to a star, and S3 plus equal to a star. Actually, I can make it look nice. S1, S2, S3 equals S1 plus a star, S2 plus a star, and S3 plus a star, right? And then when we start, before I3 in range, N3 to 0, right? Then we basically have 2 scenarios, right? We have 2 scenarios, so we're gonna say for I3, so the remaining is Right, we have 1. Hold on. Alright, I'm back. I can't believe this one is, I solved it using recursion so fast, but the bottom up just took me so long and I'm still not 100% sure. So for each one and I3, then I need to see for what? For I1 in range what? Actually, for I1 in range, no. This is going to be n3 minus 1. It should be how many positions, right? How many positions? How many positions? So we're going to say in range, okay, so we match 0 position. Right, we can say we match from 0 position to n3 minus I3. n3 minus I3 is the number of digits we need to match. So we can match, like S1, we can match from, it's actually from 1 position. So it's not going to be, it's just, I have to call it M. We match 1 position until n3 minus I3 number of letters. So n3 minus, if we start from here, n3 minus this will be 1, so it has to be plus 1. And that number of positions, right? And then we just need to see if S1 S1 N1 minus M, right? That's number of positions. If that is equal to if that is equal to I3, right? Equal to I3, which means it's S3 I3, right? If this is equal, then we say dp I3. This is going to be N1 minus M is equal to, this is the current S2. S2 would be depending on what? On N3 minus I3, right? That's the number, and minus M, right? This N3 minus I3 is the total number on S3 when we want to match, minus M. M is the number we matched on S1, so minus that, and remaining is that's the number of letters to match on S2, and the S2 will be N2 minus this. This feels a bit more convoluted. The N or not? No, I don't think I like this. And I'd rather just plus 1. I think that will be easier for me to handle. And I think a few things will be, we'll probably have to pre-fill a few of them as true. So it's like dp n1, n2, n3 will be true. And yeah, so I'm going to say dp n3, n2, n1, that's going to be true. Then it's going to be range and stuff from n3. No, it's actually not starting from n3 because we want the first letter, so that's n2 minus 1. And m range is true. And this is n1 minus m. Yes, that's also true. Then we say n2 minus total number, and this one will equal to dp. All right. So we say we want S1 to match to this, S2 is matching to this, and we say now this one match, then it will depend on we say this one, so something on S1 matches the current letter, right? So whether it matches or not will become the next one if we match. Depending on whether the next one is going to match on S2 or match on S1. If next one we still match on the current one is this, so next one could be S2, right? So S2 is matched on next one, then so S1 is matching on this, right? So if we want to match the next one, S1 will be 1, and S2 will be this, right? Or I see the next one still is this one, then like if the current one on S1 is a match, alright, so S1 already matched to this one, then S1 has a remaining, and S2 has this. We try to match one on S1, and then S2 has to be this, right? Because we have this plus this must be this. And S1 say match on this, then the remaining must be this, this, and this to match. Okay, so that means because we're trying to match S1, so 3 minus 1, no, I3 plus 1, right? And the I3 plus 1. I3 plus 1, and 2 doesn't change. Well, we can just say I2 equals N2 minus N3 minus I3 minus M, right? And then also say I1 equals to N1 minus M, and we can just say if I1 is equal, then I2 I1 will equal to plus 1 I2 and I1 plus 1. Alright? So whether is matched depending on the next one. If we say this is matching, right? And then the remaining is this and this, and we need to see if they match. Else, I mean this one doesn't match, then we can just say this one is false. Right? This one will be false. And then because we already set false, so we don't have to do anything. So if it matches this, so that's, we want to match I1 first, right? And we can also say I want to match M, say for N goes 1 to N3 minus I3 plus 1. So it's the same, but this time we want to match all I2, right? So we say I2 equals N2 minus N, right? I1 equals N1 minus, not M, N. It's going to be N, right? So we're going to try to match S2 from 1 to all the way to all. And then we say if S2 I2 equals this, then this equals to I2 plus 1 and I1. So once we go through all this, we're going to return it's just dp 0, 0, 0. I'm not sure. This looks not confident at all. C. Ay. A list out of range. Why is the list out of range? Everything is already +1. Top level is in 3. Second level is in 2. First level is in 1. Right? And then I3 is going to be from N3 minus 1. Yeah, from N3 minus 1. So because we can do N3, so N3 minus 1. M is going to be 1 all the way to N3 minus I3. So N3 minus I3 is the number of letters, right, on S3. It's left that haven't been matched. And we need the +1 because we need to get to that level. So at the beginning, this is going to be 2, so M is going to be 1. So I1 is going to be N1 minus 1, which is true, which is this one. I2 is going to be N2 minus, oh, I think I find the reason. This has to be parentheses, right? Yeah, parentheses. This one will be 1, and this one will also be, M is going to be 1. So minus, actually has to be this, right? So I2 is a 0. Now I2 is equal to N2 to start with, which is fine. So we're going to change this one as well. I think it has to be this. Try it again. Oh, we pass. Oh, I think that is the DP solution. Oh my god, it took me like what, 45 minutes, more than 45 minutes to figure this out. Try it. Come on. What happened? Pending. Runtime error. String out of range. Huh. How? Well, because it is not possible. I thought we can avoid this. So N3 has something. N1 doesn't have anything. N1 is 0. Okay. N3. I think we just do a check. Let's say if I1 is smaller than N1, and we do a check. So do a check. I2 smaller than N2, and I think this one will pass because if we do a check, it should be fine. Ah. What is this? Index still out of range. Which one is out of range? I1 shall be fine, I3 shall be fine as well. Weird. If I1 is smaller than M1, so I1 is smaller than M1. So problem is not with this, but with this. You're telling me I3 is out of range. How is I3 out of range? But I start from N3 minus 1. It's weird. Okay, let's do this. So I1 smaller than M1 and right, and this is I2 smaller than N2 and we have our test case as of empty, empty, and A. It must be false. Right, no question asked. And let's just see which one is causing us trouble. Right, which one is causing us trouble? Let's just run before. We're going to print I1 and I3. Let's take a look at what we have. I1 is minus 1. Oh. Because M1 is 0. M is 1. There we go. That's the reason. Okay, so easy. We'll just put another constraint here. Right? Put another constraint. Constraint on this. Then we're good. Yep. Just put one more constraint. One more constraint. And we are good to go. Try it again. Wrong answer. That's not correct. I expected true, output is false. So I didn't quite get the bottom up. So what's this? What's this one? AABC, and what ABAD, and the last one is AABC ABAD. Right? This one's supposed to be true, but I got false. AABC ABAD, yeah. How is this one? How did I now get it? So last is a D, so I compare, right? I compare for M in range 1 to it's only 1, so I try to do I is not good, so I try to do this, and this is good, right? This is good. And then go on to the A, and this is also good. Go on to the B, this is also good. Go on to the A, I think this one will be good. So yeah, it'll be hard to see the DP. Let's see what's going to happen if we print DP. Oh my goodness. For M for mat in DP, right? You just print mat, so it will be a little bit easier to see. Everything is false. So for M in range, let's see, 1. Let's say I3 is going to be here, right? I3 is going to be here. So N3 minus I3 gives us, this one is 3, so it's going to be 1 to 3, right? N going to be 1 to 3. So let's say I'm going to match 1. N2 minus 1, yeah, I'm going to match 1. That is no match. Right, that's a no match. Then minus 3, and then minus 3. Minus 1, minus 2, minus 3. So N minus 3 is here. And then n, I1 will be equal to, this is 3, minus 3 is 0. So I1 is in here, and 1. And we say this, and it matches, right? It matches. So say that as a match. So this one will equal to I3 plus 1, and I2 plus 1, and I1 as a match. So it should be a match, right? So yeah, let's print some. So let's print dp minus 3, and also I2 is minus 3, and oh, hold on. dp is actually, I think it's because dp is 1 mole. dp is 1 mole. So dp is 1 mole. We have to go in the front. So let's be 0, 1, 2, 3, 4, 5, right? It'll be 5. It's going to be 0, 1. That is going to be 0, 1, 2, 3. That's going to be 4. Yes, that's a true, right? That's a true. And we can keep going. Like say, if it's a 4, that's going to be 0. That's also true. Yeah, that's what we expect. And then we're at here, right? We're at here. If we're at here, then what we're looking at is this. Uh, 1, now we match, right? So for m in range 1 and n1 minus 1, this one is a match. So we say, if it's a match, we can say this one will equal to dp this. So I2 equals n3 minus I3. n3 minus I3 is 1, 2, 3, 4, 5, right? So it's a 5. It's a 5. That is a 5. So 5 minus 1 is 4. And n2 is a 4 minus 4 is 0. So I2 is a 0. But I2, well, I think it might be the problem here. Like we have a 5, 1, now I have 4. So this one can be 0. Yeah, which is true. So we're gonna match. So this one will be match 0, 1, 2, 3. This one gonna match 3. This is gonna be, so match 3, and then I2 is gonna be 4. So match this and this. We're gonna match to this. Yes, equal to this plus 1. So that plus 1 is here, and I2 is here. Yes, I1 plus, so I think this one should be fine, right? So this is going to be 0, 1, 2, 0, 1, 2, 3, right? This is going to be 0, and this has to be 0, 1, 2, 3 as well. That's still true, yes. So this one will be all false, right? In range 25, and then we're going to try to match every single one. And then even if we match, I think the remainder will be false. So anyway, so that's a true. So now we're going to go to 2, 0, 1, 2, right? 2. If I go to 2, and m will be That's 6, right? M can be 1 to 6. M can be 1 to 6, and then, yeah, M can be 1 to 6. So still, I'm going to go 1, but that's going to be a no match. So M going to be 2, right? So if M is a 2, it is a 6 minus 2 is 4, so I2 is still 0. So which means, I think this one should still be true. Yeah, which means 1 is a false. Hold on, so we say 2 is a true. So at 2, we still work, right? 2, 0, 1, 2, we still work. And then we go 1 before, right? We go 1 before, and so M is here, I3 is here, 0, 1, and let's see what we have. So for M, it's going to be 1, 2. Yeah, this is actually not true. This has to be like the minimum of N1 to this, right? The minimum of this, and this is going to be the minimum of N2 and this. Yeah. So for M, it's going to be 1, 2, whatever, right? And then I want and did this. That's a no-go. And 1, 2, 3. Right, and 1 is 3. That's 1. If it's a 3, that's a 6. That's actually 1, 2, 3, 4, 5, 6, 7. So I2 is still 0. And A is a match, right? It's a match. So that will equal to this plus 1. That should be true, right? That should be true. Why does it give us false? I don't understand. Because 202 is all right. Let's see. Say if I1 is 1 and I3 is 1. All right. I'm going to print BP 2, 0, 2. I'm going to comment on this. It's a false. It's a false. Hold on, what the hell? That should be a false. But let's see. False, 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 false. No way. Are you telling me that it becomes true in the bottom? What? But how is this one becomes true? No, it's not true. Wait, earlier it's true. Earlier is true, right? Wait, what? We saw it as true. Wait, hold on. It was true. This doesn't make any sense. Um, 3, 4. These shall all be true. Hold on. 4, 4. 8. No. List out of range. How? Oh, I got it wrong. This be 8, 4, 4. All right, that's a true. And then we say 0, 1, 2, 3. Right, that's a 3. And the 3. 0, 0, 1, 2, 3, 4. That's a 4. And this 1 is going to be a 4. This one is going to be 0. Now we have a problem, a serious problem. Alright, so go to 1. 0, 1, 2, 3, 4, 5, 6, 7. Right, so it's a 7. And the second one is 0, 1, 2, 3. It's 3. That should be a true. Yeah? And then if it's a 6 and a 2, that's a true. It's a 5, that's a 1. Still true. 4, 0. That's the problem. 4, 0 is the problem. So we have 5, 1. 5, 1 is still true, right? So 0, 1, 0, 1, 2, 3, 4, 5. It's still true. And then the next one we go to here. 0, 1, 2, 3, 4. Right? I3 is 4. And we don't care about this because this is not going to work anyway. And then we're looking here. Minimum and 2. And 3. And 3 is 8 minus 5. 3 plus 1, that's 4. Right? Both are 4. Right? So which means we can have 1 to 4. Right? So we have 1 into minus n 1, which is 3. That's no go. N is 2, 3. N can be 4. Right? N can be 4. N is 4, so I2 is 0. Right? Then I2 and S2 0 equal S3 0. Right? And then say dp this and n1 because n3 minus I3 is 4 minus n is 4 is 0, so n equals n1, right? And then that should equal to dp I3 plus 1 is here, I2 plus 1, which is 5, 1, 4, right? So it should be right. I2, I3. 3, 7, 2, 6, 1, 4, 1, 5, 2, 4. How do we have 2, 4? I2 is 2. 0, 1, 2. Oh, we do have 2. and it's no good, but we keep going. Why we don't keep going? We keep going, right? Into, also print n. Yeah, n is 2. We can do 3, and that's no match. And then we can do 4, right? N2 shall be able to give us 4. Because I3 is 4. Oh, N2. N1 has to be plus 1. Ah, that's correct. Has to be plus 1. Now I see. Now we're true. Okay, now we're true. Now we haven't solved anything yet, so now 202 becomes true. Right? Now 202 becomes true. Yes? If 202 becomes true, and it's telling me 101 is false, okay, now we have a problem. So 202 is true. So 202 is 012. This is going to be 0 and 012. 012, right? That's good. Now going back, now we're going to be 1. And N3 is 1. No, I3 is 1. It's 8 minus 1. That's 7. That's 6. 6 plus 1. That's 7. Right? That's 7. So we're going to go 7, but we don't have 7. We only have 4, 5. So we're going to do 4. 1, 2, 3, 4. Right? 1, 2, 3, 4. So we check this. That's a no match. And also, if we check this, N2 is going to be hold on. N3 minus, that's 7, right? That's 7 minus M. 7 minus M. M is 1. So this is going to take, I think this has something we need to do. Like I2. I2 is smaller than, so if, so we're going to do another one. Yep, so we're going to do this one as well. So we have 2 checks. Every time we're going to do both checks. And this, right? Now we can do this as well. This and this. Okay. Apparently that's not a, but yeah, but that's fine because this is not doing, right? Not doing anything. And but anyway, like we have to go to 4, m equals 4, right? M equals 4, and I1 is become, no, m not equal to 4. Minimum, so we're going to take 1, 2, 3, 4, right? So we are at here, and we're going to take m equals 3, right? M equals 3, I1 is 1, m is 3, 7, minus 3 is 4, right? And I2 is 0, so this good, this is good, and I'm going to print I1, I2, I3. Yeah, I'm just gonna go I3, I2, I1, so it's easier for me to handle. See, 101. We have 101. Right? It's 101, and we do this. In fact, let me just print 101 here, not print here. Huh. So I'm gonna print here 2, 202. 202 are all false. But if we print 202 here, it happened again. It happened again. It becomes false. Wait, what? We saw it was true earlier. Oh, smaller or equal. Because I2 we can take, yeah. Actually, I1 can take it as well, I think. No, I1 cannot take, because I1 we have to do this, but I2 and I1 can take. There we go, now we can become true again. It's like, okay. Let's try this again. True, we get true, 0, 0 is true. Do we get true on this one? Oh, I guess one, this is false. But, oh no, it's true is on 202 is true. So if 202 is true, which means after this, if we print 101, that should be true. Yeah, 101 is true, true. And then it turns into false. Something changed 101. Something changed 101. Something changed 101. There's something here changed 101. How? How is that possible? Oh man. Okay, when I change the strategy, it means like if I already set it, then do not change it. Something like this, right? So if in this, then we say, like if it's a false, then we can change it to true. But if it's a true, then we don't change it to false, right? So if this, and not dp I3, I2, I1, right? So this is basically just saying, if I have found something that can make it work, then do not make it worse. Just keep it working. There we go, now we pass. So yes, that's like something else is messing it up. I don't know what, but Basically, I think what this says is, first of all, like I1, I2 must be valid, and if this is the same, and if we have not recorded yet, if we have recorded it already, then we do not change it, right? And if it's a false, then we can always change it. But if it's not a false, then we do not change it. All right, just try to see if these all pass. All right, hopefully this one will pass. It's such an effort to get this one done. Yeah, oh my god. Oh my goodness. No, this is definitely not the solution. Yeah, I really want to see it. So this is my attempt at bottom up, but very poorly done. Took me like almost. It took me an hour and a half. It took me an hour and a half just to come up with this, which itself is very slow, very slow. So still, this is the standard, and I don't want to keep digging. I want to see what the smart people say. Gotta be an easier way to do bottom up. This is convoluted. Brute force. Medium question. Yeah, it's a medium question. And brute force recursion with memo. Yeah, I think recursion with memo. This is recursion with memo. Works. M times n. Oh. 2D dynamic. Wait, we don't have to handle I3? Okay, I'll read it. 2D dynamic. One D dynamic. Yeah, I kind of see that this is. All right, let's see. I think it's probably different. But there will be cases encountered in which the same position of what has been processed already, but in different orders. If the resultant string form till now is matching as required, the final result is dependent only on the remaining portion. First leads to a computation or whatever. 3-pointer. I have 3 pointers. Index of the current character. Yeah. Maintain a 2D memo to keep track of the substring processed so far. It stores, depending on whether the current position string up to ith for S1 and j has already been evaluated. Again, we start by selecting the current character as S1. If it matches the current character as 3, we include in the process string and call the same function again as I plus 1. That's the same idea. I think feel like it's the same idea. If I to the end and remaining S2 equals remaining S3, that's good. If j equals, yes. If now you do equal to 0, turn this equal to 1. Why do you do this? You just equal to 1. Three at this equals to 1, and interleaving, or actually 2 is j, leaving this, that is true. Now equals answer 1 0, return answer. Even memo initialize to -1 and then it's interleaving. I feel like it's the same, but they don't have to consider S3 because I3 is taken care of in here, only used when they compare. So it's slightly different. So I am saying compare each letters. They're saying the current position of S1, S2, right? The current position S1 and S2. Now we say if the current letter on S3 matches S1, then what we do is the remaining of just this one and or this one. I feel like these two are the same. I just don't have a DP table. If at these three positions they're the same, right? One of them is the same. Or hold on, let me think about it again. So we have three indices, right? And at a one position indices, if one is the same, right? And then I say S1 gonna plus 1 and S3 K gonna plus 1 and then J doesn't change. Yeah, that's exactly the same thing as what I have. Or we can match on the other one. Yeah, we can match on the other one. If both give us true. Okay, so, but why is this? Because the substring, they just consider that as a 1. Each combination of ij is computed once. Yes, each ij, I agree. Each ij is computed once. No, in your case, you say ij is computed multiple times because for each I3, you say we're going to have. That is the question. How I3 plays in this? I think I3 is not playing a part. That's troubling. That's troubling me because I thought I3 plays a part. And this, I don't want to look at this. This is terrible. Absolutely disgusting. All right, let's try it again. So, same recursion, but with different perspective, right? So here this is from the official solution. The idea is that we pick all combinations. The ideal is the same, right? It's the same. This is from the official solution. We use 3 indices. Yeah, it's the same. It's exactly the same, but just with slightly different. Yeah, this is the same, but with slightly different. No, this is exactly the same. We have 3 indices, and we're comparing 2, and if it's good, then we move on. If it's not good, then we try the other one, and I also always try two situations. So note, according to the solution, the runtime is OMN. K does not play a part. I still don't know why K doesn't play a part. Well, K doesn't play a part because at each one, your K just increment. Yeah, you should see here, there's no change in K. Whatever we do here, K just increment. So K always track on the increase on one of these. So the interplay is just these two, like I1 plus 1, I2, I1, I2 plus 1. So this one has a cross, and this one will give us OMN. But this one just tags along. Every time we call this is always plus 1, always plus 1. So there's no difference. It's not like with this gonna have all different combinations. That's right. Yes. So slightly different implementation. Okay, I want to implement this. This might help me think about the other solution. So slightly different implementation. How do we implement this, right? So again, I like to put this at the beginning, right? This one at the beginning, and then def helper S1, I1, I2, I3, exactly the same, right? Int and int and int, boolean, right? And we just say if I1 is equal to N1, which means I1 has done. Now we're going to return S2, I2 equal to S3, I3, right? Same thing we can apply to I2 equals this, that's 1 equals this, right? If nothing like this, then we can compare. We can say if I1, if S1 I1 equal to S3 I3, and so S1 S3, and then we go to the next level, helper, and helper I1 plus 1, I2, I3 plus 1. Right, so if this or same thing. Actually, I'm just gonna keep writing. Oh, this is gonna be S2, I2, helper S1, S2 plus 1, right? If it's this, so it's two situations, right? S1 and S3. S1 matches, and actually this is not. This one. S1 matches, and move on, still matches. Then in this situation, we say we're gonna return true, right? Else we're gonna return false, and then we're gonna also create. It's gonna be at LRU cache max size equals none. So once we've done that, we're just going to return helper 0, 0, 0. So this is selection 3. Yep. And 3 never used. Yeah, we don't have to use N3, that's true. So that's that. So it kind of gives us an idea that N3 is not involved. So this is just It should be the same runtime as the other one. Yeah, I actually like this one better because it's more straightforward. String out of range. I guess we have to check. Yep. We have to check. But why do we have to check? It doesn't make any sense. Well, because S3 can be done, but S1, S2 is not done. So I'm going to say if S3, if I3 equals N3, and here we go, N3, here comes N3, return I1 equals N1 and I2 equals N2. So we do need N3. And then is 3, right? So let's try this test case with our new one. I'll put all the check at the beginning to make it easier to handle. Yeah, this one should be right. Yeah. All right, bottom up. So we know that this is MN. All right, so we have a DP table, a 2D DP table, and we at this index. Basically, it's just saying at these two index, do we have, like, if it's a match, what is the I3 value, right? Is that what it's trying to say? Like, I'm still thinking from back to the front, So if I say, like, I'm at here and here, I'm at here and here, and then we can match to this value, right? And if I'm here and here, then I can match nothing. Here I can match nothing. And then I say if I'm at any position, right? Any position, say I'm at this position and this position, I want to see what can we match. I think I still have trouble, even if I kind of see how this one's going. What is the DPI? So it's beginning, if we match, going to be match A, and from here we're going to match nothing, right? Or we're going to match A and D, A and then these are all going to be false because they just, wait, what? Wait, hold on. Because we have 2, so we say, like, we're ending here. Okay, we can go from front, right? We're ending in here, so we can only match two letters, right? So we say we can match, let's say we want to match A, and this has to match A, but it doesn't match A, so that's a false. And then we're moving on, right, it's here. And then we say first match A, and then we need to match DB. It doesn't match DB. So we basically run this twice. Do we run this twice? No, we don't run this twice. Oh, we don't have to, because like it's A and DB, A and then DBB, right? A and DBB. So we say we're gonna match A, and we match DBB, that's a false. And then A, and then there's a false, it's all false. Now we're gonna match AA. We match AA, that's a match. And then we're gonna match AAD, that's a match. And AADB, that's a match. AADBB as a match. That's also a match. This is not a match. Now we're gonna go match 3, the front, right? And then we're trying to match D. That's gonna be. Oh, hold on. AA. How does this work? So we match AA. So we add B, right? So we add AAB and we add D. So we can do AABD, AABD, or AA. So we know AAD is a match. So we can add this. So we're at here, and we say the front basically everything before is all possible matches, right? And we're looking to the left. If we look to the left, that means we're going to match AAB and match D. And we look above, that means we're going to match AA, we match AAD, and we match this, and we match B. So every single time, we have two choices, either to match this or match this. If we want to match this, we look at here. If we want to match this, we look above. Let me go through this again. So we have a string, right? And then we have a certain, so what we want is the DP table tells us at a certain position what is all the combinations. Combination of all matches before me. Right? If there's 1, it's going to be, if I have 1 letter, right? So I'm going to say we're going to match either 1 of this, and if it match, then that should be a match. So if we'll match 1 of this and none of this, right? And we also can do, if we want to match 1 of this and none of this. So that's why we have the first column. So for 1, then we say we want to match 1 of this and none of this. So that's here, right? And if it's none of none, it's going to be no match. So match 1 of this and none of this. And and we're going to grow 2. I also have this. Let's match none of. Oh, we have match none of this and a 1 of this. None of this and 2 of this. None of this and 3 of this. Now we have 1 of this and none of this. Now 1 of this, 2 of this, 1 of this, 3 of this. But doesn't this like always match? But we can say, will the order matter? Doesn't it always match S1 first? What if we put the DB BCA here and put A here? I think then the table should be transposed. Yeah, because at each one we can choose either to, at each position we can choose either to match this, right? Or match this, we go here. Or match this, we go here. And then we will always just go up. Ah, that makes sense. Yeah, so at each position, right, at each table, it's going to be an INJ, right? An INJ for the S3, for S3 we can only match one letter, right? If we want to match the top and the top, then we need to compare to the left. And if we match on the left, we need to compare to the up. And both of these are okay, so I think I got the gist of this. So that's the correct way to do DP. The correct way to do bottom up DP. Right, so DP is going to be false times. Again, we're going to do n1 and 2 equals len s1, len s2. So this is going to be n2 for this in range n1, right? And then what we do is also have to include n3. So actually, I think this has to be plus 1. This also has to be plus 1. Yeah, so we start from a nothing position, right? So I'm going to say for I in range n1 plus 1, for j in range n2 plus 1, right? So n1 is 0, n2 is j is also 0, and if I equals j equals 0, dp ij is going to be true, right? Else for each one, then we can do so else is going to be for k in range what? K in range j, right? And then for I in range, right? And then for j in this. Else, if both are 0, and that's a true. Else, I think it's just as j going along, right? As j going along. So we're gonna say as j goes along, either we're gonna choose. Right? We're gonna choose. So we say, what's the choice? The choice is I can either match we can match to so if S3, right? I plus j, right? I plus j. If S3 I plus j is, I can actually do this. Let's say if n1 plus n2 not equal to n3, it can false immediately. So if S3 I plus j is equal to S1, we're talking about row, S1 I, well, it depends. I think for j in range, so this one is true, 0, 0 is true, right? And now we say for j in range, so n2 dp 0 j equals I'm trying to fit. Yes, so like so j equals less 2j equals S3j and SDP 0 j minus 1. Right? And the same thing for I in range 1 to n1, dpi 0 is 1 equals S3 I and dp I minus 1 0. So go through this, and then we can do I in range 1 to oh shoot, it's 1 plus everything. So This has to be -1. Yeah, it has to be -1 on all the string reference. Now they can go from 1, right? And then you can say if I plus j -1, right, equals -1, yeah, so at this position, if it's equal to the S1, then so I think if this equals this, and dp to be what? So we're saying on a row, right? It matches. So let's say the row -1. So row -1, I -1, j. This or S3, I plus j -1 equals S2, j -1. And dp if a match, basically match j, match the column, then we need to say the same I, but j -1. If any one of these matches, then we say dp I j is true. Otherwise, it's false. Oh. And if we do this, we're going to return dp n1 n2. Okay, so this is my solution. The last one. We fail on the last one. Why is that? Okay. I don't know. This one we can print a dp table. Okay, for row in dp, print row, right? So true. So this is A B A D. No, yeah, A B A D, A B A B C. It's trouble. There's trouble because this one shall match A, B. This one shall be true. I don't know why this is false. Range 1 to N1. J ranging from, because 0, 0 is already true, so from 1 to this plus 1 to this plus 1. There we go. Now we pass. That makes more sense now. Okay, let's try it. So this is better DP. One more test case. Should be fine. Like this. Yep, so this is good. And the last one, solution 5. Solution 5. So same DP, but using 1D table. So basically, you can see this. So we are only using one rows, right? We're only using one rows. So we can do some magic to use only one rows. Let's see, how can we use only one rows? We can use one rows by so like this one is the previous value, so it can be the current value. So we compute this value, right? And this one is basically this. So we can say this equals this, and this is already updated. But we cannot update it, right? We do not update it. We need to know the previous value instead of the current. Therefore, we need to go from here back. Because what we need to know is the previous, hold on, the previous value. No, we can't use the previous value. It's a compute the previous value. So these are the same, right? These are the same. And dp is going just to be false times n2, right? False times n2. And dp0 is going to be true. This is the starting position. And actually, we can also do this one. This is fine. This is the initial. This is the initial. And it's just going to be dpj equal to s equals this, and dpj minus 1. Yeah? Now we're going to do this. And of course, I think I can take, now I take 1. J has to take from 0. Yeah, J has to take from 0. J has to take from 0, right? And then we're just going to say, if J equals 0, if J equals 0, then dp0 equals dp0 equals s1 I minus 1, right? Equals s3 I minus 1, and dp0. Else J is not, then dpj equal to equal to two scenarios, right? Else, elif, right? Elif, same situation here. So elif is 3 I plus j minus 1 equals s1, so equal to s1, right? S3 and S1 is equal, and we're gonna go for this, so that's just gonna be j minus 1, or S3 equals j, that is just going to be dpj. And this will cause dpj equals to true. I don't think these two can be combined, right? Actually, it can. I think it can, because if it's evaluated true, is it or, we can short circuit it, so we don't have to. Which means we don't need this. We can just directly say, and I can just go from Yeah, I has to go from 1. But how about this one? This is the first row. It should be equals j. But here, it's equals j minus 1. Okay, this is the same as this. We're just doing the first row. Yeah, okay, this one is necessary because that's different from other lot because there's no a row above it. So this is the first one. This and have a row above it. And actually, we don't have to do an if. This is just going to be dpj equals this. Right? dpj equals this. There's no if. There ain't no if. It's just dpj equals this. dpj equals, like, we can still do this if it's equal to s1, right? If it's equal to s1, and dpj. Oh, but what if it's a false? Then good point. What if it's a false? Well, what we need to do is make sure that if it's a true, then we do. If it's not true, we just make sure j is larger or equal to 1. Yeah, just make sure j is larger or equal to 1 and this. That should be fine, right? So if j is not larger or equal to 1, we cannot do yeah, the problem, no, hold on. The problem is we're looking at looking at j is 0, right? When j is 0, wait. Why are we having this situation? We're having this trouble because for I, like for each j, so I is starting from 1, but j can be 0, right? So it's when j is 0. When j is 0, when j is 0, if I matches, right? If I matches, then what we need to do is to go a row of, yeah, if I matches, we need to go a row above, right? If I matches, we need to go a row above. If I matches, I think we got it wrong. If j matches, we need to go j minus 1. If I matches, we need to go a row above, right? And then j can be starting with 0. Right, j can start with 0. So, and if my I matches, right? If my I matches and dpj, which actually should be my I matches. If my I matches, should be I minus 1, which is the previous j's position. That's actually true. So the problem is with this, if the j matches, then we need to go j minus 1, but j is 0, so there's no j minus 1, right? If j matches, think again. So we're at any position, right? If I matches, the row matches, then we want to look row above, which is the previous j value, so which is dpj, right? Yes, dpj is the previous row. If j matches, then we need to do j minus 1, because that's the previous one. We need to do j minus 1. So the problem is on the first row, we can only match in j, which is actually fine. We don't have to set it into a separate. But the problem is when we go to each one, there's no j minus 1 when j is 0, right? When j is 0, whatever I it is, when j is 0, right? When j is 0, when j is 0, if I matches, then we take dpj, that's fine. But if j matches, then what? J is 0. If j is 0, then we cannot match. It's only going to be I. Yeah, so if j is 0, then we can do this, but we have j larger equal to 1. Therefore, we don't have to worry about the j minus 1. So if j is 0, then we don't worry about it. We combine these two together. We say this one must be I is larger equal to 1. Yeah, we can say I is larger equal to 1 and dj. So we can just start with this. Right, so this one will be false. So we force to use this. Right? Which means I don't think I need to use this anymore. Right, and then we end this, and we say I equals j equals 0, or if it's not true, then we try I larger than 1, right? So that's also false, like I is 0. Now we go here, j, and if this equals to j, then j minus 1. Okay, and then this one will return dp minus 1. All right, question 5. Invalid syntax. Oh, it's not me, it's here. Index out of range. The I and j will be the I and j. I think this is the problem. It's going to be plus 1. There we go. This is a 1D array. Yep, 1D array. Very convoluted. Well, actually, it's not convoluted. It makes sense, right? It makes sense. It just this one can take on the outside, and then we still have to do check. Now then we try this, right? And then yeah, it's basically just saying if I want to go left, if I want to go up, is itself. If I want to go left, it's going to be j minus 1. All right, I don't want to go through this question. We go through all the. I have not done this before. Pretty poor performance. I mean, it's almost 3 hours. We solved the problem in like 15 minutes, 15 to 20 minutes, right? We solved it in 15 to 20 minutes, but it took us, geez, I don't know how long to figure out the bottom-up solution. It still needs some time to digest. All right, anyway, that's late. So see you guys tomorrow. Adios.